Red fire first, concentric, radial crack, concentric. The second bullet fire, the entry point, which is the entry point, the radial cracks, and the concentric pattern. Exit point, mas nidako yung concentric pattern dre. Tapos taas kaya ang radial cracks. Dre ni mo mapil ang crack niya dili dre sa tubangan. Dre sa exit point mo timananan sa exit point. Dre ni mo ko na cracks.
So as we go through our discussion, we will identify first what is glass. So this is the example of a glass. Glass is normally a fused mixture of silica, usually in the form of natural sand, and 2 or more alkaline bases such as soda, lime, or potash. It also contains quantities of various other elements and metals present either as incidental impurities in the bases, constituents, or added to them for color, degrees of hardness, heat resistance, and other specific purposes. So there are 3 properties of glass. Glass is somewhat flexible. It tends to bend upon application of force. Number 2, glass bends in the direction where force is applied, causing the opposite side to stretch. Last one is, glass can withstand more bending rather than stretching, causing the opposite side to start breaking. Entrance and exit hole. Point of entry is where the force is being applied and it may produce a smaller hole than the exit. The exit is bigger than the entry for the reason that the force applied at the glass exceeded its desired force. Point of entry has a smooth hole while the exit hole has the characteristics of roughness.
So now, after the gunshot fired with the 9mm caliber, we can see as the glass clearly were formed by the penetration, the fracture, originating from the center is what we call the radial fractures. And then, we can see the fractures were formed by circular pattern at the center, or the spider web is what we call concentric pattern. So to further understand more, let Ms. Buyok explain us to what are the types of a glass fractures.
There are 3 types of glass fractures. Number 1 is radial fractures. So as you can see, the glass is the radial fractures. So radial fracture is a primary fracture resemblance to the spokes of a wheel. When glass breaks, the liners that radiate from the hole are caused by the glass bending away from the point of impact. So what is point of impact? An impact on a pane of glass causes it to bulge. Since the side opposite the impact is stretched more, it ruptures first. Ridges will be seen as irregularities on the broken edge of the radial cracks. These ridges tend to be perpendicular to the side opposite the impact and parallel to the side of impact. The radial fractures originate on the opposite side of the glass, because this is the surface which is the first to feel the tension. As the front of the glass is pushed in the opposite side and is bent backward. When the limit of glass elasticity is reached, it breaks with cracking resulting along the radial lines. Number 2, concentric fractures. And this is the concentric fractures. Concentric fractures, secondary fractures, having the appearance of circles around the point of impact connecting one radiating cracks to other, thus forming a triangular piece of glass. While the radial fractures are forming, triangles are created between the fractures. The newly formed triangle glass between the radial fractures also bends away from the direction of force. When limit of elasticity for triangles is reached, the glass breaks in concentric line. Concentric fractures originate on the front of the glass. The last one is the conchoidal fracture. Conchoidal fractures, a characteristics of glass is that when it breaks, the fracture's edges appear shell-like in form. That is, having elevations or depressions in the shape of a shell. The technical name for this condition is conchoidal.
But let's look at the fracture and the penetration. So once again, we can see a radial and a concentric fractures. So this is the concentric fracture, the radial fractures. So this is also a concentric fracture of a second penetration. We can tell this is the radial fracture because it is the fractures radiating to the center of a penetration. But if we look closely at the edge of a penetration, we can see its slopes. So this is the slopes, guys, in toward the center of a penetration. That's what we call a crater. This is the crater, guys. And what we are actually observing right now is the crater. The crater affects essentially the side, opposite the side from where the force of this case, the projectile came from the forms or cratered appearance. So you can always tell which is the direction a penetration originated from the analyzing glass. So when we analyzing glass, it is a perpendicular shot. So remember, it kind of goes in small. So as we can see in the entry point, we can see the small holes, and in the exit point, we can see the holes much bigger. You can see this actually and feel with your fingers. So that it is our first penetration. Let's see the second penetration and see how the two penetration interact their fracture patterns. Alright, if we look very closely, our penetrations, I can see the radial fractures from our second penetration, reading it with our concentric fractures. So guys, you can also identify what is the kind of bullet and guns passes through here at the glass, with determining the measure of its crater by the help of these measuring tools, the caliper. So let's measure first the first penetration. So as we can see here, there are 0.6 inches causes with the 9mm bullet passes here at the glass with the distance of from 4 to 5 meters. So let's go to the second penetration. So as we can see here, guys, it is also 0.6 inches with the same bullet and same distance. We can identify where is the gun or where is the bullet fire first with the help of their fractures. As we can see, this is the first penetration because with the first bullet passes here at the glass by the helping of its fractures or its radial fractures.